Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗟𝗟𝗟𝗟 and today we're gonna talk about the format string vulnerability. So what is a format string vulnerability? Imagine we have the family of printf functions, like here, and we know that our variables have types. For example, we have an integer, a short integer, long integer, a double, a character, a char buffer, which is actually an array, a string, and in order to represent them, in order to print them to std out, we have some type of formats. Like for example, for the integer is %d, short int %hd, long int ld, double f, and we can specify the decimal point here. And for char is %c, and for strings arrays is %s. And we can see that here everything is printed correctly. For example, we can change that to 1 and we can see 6.9 instead of 6.90, and we can see that if we, let's say, use a wrong format, okay, sometimes the output is still correct, but we get a warning that we messed up with the formatting. As we can see, we have the formatting in order to represent the data variable we have next to it. But could we do something like printf, let's say a, and printf b, c, d, e, and buff. Let's comment out this and see what we get. And oh my god, let's run it again, and we see that we get too many errors here, and yeah, it's a bit messed up. Let's try one by one. Segmentation fault, alright, and let's try with, it's gonna be the same for everything. I think only buff is gonna be good. Yeah, only buff is good, and probably the character. Yeah, no, not even that. So only this one was outputted correctly and the other ones failed. But still we see that in this case printf actually worked. So let's head into the bug right now. Let's say we have the main function here and we initialize the flag buffer with 0x10, initialize with 0, char input 0x30, and we try to open the flag here, the flag txt, and we read it. If we don't have the flag, let's say I remove flag txt and we run the program, and like this, we see something bad happened with flag txt, no such file or directory. Otherwise, if we do, let's say, echo 𝗪𝗟𝗟𝗟𝗪 inside flag txt, now it does not produce this error, and what it does is actually fgets from the file pointer here, from flag txt it reads up to 0x10 bytes and puts them in the flag buffer, and after that we see, do you want me to show the flag, and it reads up to 0x2f bytes into the input buffer, and there is no overflow here. 0x2f is smaller than 0x30, and after that it says printf your answer was, and printf our input. And here we can see the format string vulnerability. So let's try and run the program again, and we see, do you want me to show the flag? Yes. Your answer was yes. Okay, the program seems to run correctly. And 1, you might wonder why it did not crash at 1. It's an integer, and in the previous example it crashed on the integer. In this case, this isn't actually an integer. The program interprets it as a character, as a string, and not as an integer. So that's why it does not crash. It thinks that this is a character, an ASCII character, so it does not print an error. How are we gonna exploit this vulnerability? Let's say what we've learned so far from this, we saw that, let me remove that. We've learned that, for example, for an integer we have %d to represent an integer. So let's try and do %d. And we see, what the fuck is this? This is not an expected behavior. I mean, when we said 12, we got 12. When we said wet, we got wet. But when we do %d, we get this random value. And for example, if we do %ld, another random value. And okay, I'm not gonna try them everything. %s, your answer was, so the flag. So what actually happened here? What happened is that printf expects to take a formatter as the first argument, and then as a second argument what this formatter is gonna represent, what it's gonna show us. When it reads %d, it expects an integer value to be shown. And because in our program there is no formatter, it's only one argument and it is our input, it's a misplaced argument, the program, when it reads %d or % whatever, it thinks, okay, this is my first argument and I'm gonna spit on the screen what? There's no second argument. So it's gonna say, okay, my first argument is the % something you gave me, and then whatever I found on the stack, this is what I'm gonna show you. So as we saw when messing around with the formatters, we got some random values, some big integers, some strings, and some other values, integers. What else could we do here? For example, okay, we saw these formatters, but there are also some other really important formatters we can abuse. The first one is %n, which we're not gonna showcase in this example, but in order to see the formatters and how the printf function and the familiar functions work, you just go to the man page and you can search, for example, %n and what? %n, no pattern found. Okay, let's go with %p, pattern not found. Okay, yeah, because it's not with the %, I guess. It is like this. As we can see, we have the L here, which was for a long or unsigned long argument, and then we have LL and some other things we saw. So yeah, here is the n, the number of characters written so far is stored into the integer pointed to by the corresponding argument. So actually with %n we can write to specific addresses. This is a very strong formatter someone can abuse. And another one is %p and x, which is the void pointer argument is printed in a hexadecimal as if by blah blah. So what does this tell us? Let's go again and run the format string, and let's go with %p and another %p and another %p, and we see your answer was 0x something nil nil. Let's try again and enter some more. And we have these values here. Okay, nothing interesting so far. Let's go inside the debugger, and again we do bmain and run, and let me zoom out a bit. Okay, so here it initializes our buffer and it opens the flag and reads it with fgets. Then do you want me to show the flag? And we have the read here. So let's try and do some %p. And a couple more. So I think we're good here. And let's see what we got. Where am I? This was our input, and oh, no output yet. So here printf, let's see what it printed. What the fuck? Am I drunk? Oh, not yet. Yeah. Here is the output. So let's have a clean copy here. And we see we get again this address, nil nil, another address, some other values, blah 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 blah. Here we see a repeating pattern, which, let's say, what is probably as a character, and we need ord of the hex value is 0x70, and let's try 25 %p, and 20 is our space. So as we can see, this pattern here is our input, %p space, %p space, blah blah blah. So this here all our input, and we also see some other values. For example, this one seems promising, and let's go and inspect the stack at this moment. And we see here we see the string we have here, same one, and then we have this one here, and then the repeating values, and also from before we see this, which is here, and the other address here. So what we see when we use the %p, we're just actually leaking stuff from the stack. And what could possibly be this, which is here? If we do x.s and this, we see 𝗪𝗟𝗟𝗟𝗪. We see that the flag was written into the stack, it was placed here, and by abusing the format string vulnerability, we managed to actually read it. As we can see here, the flag is never printed, it's written here in the flag buffer, and it's never printed for us. The only thing that it's printed is that you want to show me the flag, our input, and then it says your answer was and our input. But in this way we managed to actually leak what was written into the stack by abusing the format string vulnerability. And as we saw here, I have made a, let's say, a helping tip, and I say that the W is 0x77, which is here, and 3 is 0x33 here. So we actually, that's why I said this string was kinda important and juicy, because we say, okay, this doesn't seem like a normal stack address or pi address or libc address. This seems like actual ASCII characters and not some gibberish. And yeah, if someone is a bit more experienced, they can see that, okay, this looks sus, let's see what we can leak from here. So this was actually a format string vulnerability. It's an old technique. The interesting part here is that we can not only use %p, %p, %p until we find what we want. We can actually do percentage, and then let's say I want the first one, second, third, 4, 5, 6, 7, 8, the 8th one, and you can do 7 %p like this, and this one should give us the string. Let's check it. No, maybe it is 8 %p. Okay, I cannot write, and 8, and yeah, as we can see here we got our actual string. This way we tell it, okay, I don't want you to split the first thing you see on the stack, I want you to go on the 8th element and print this, and we actually get our string here, our flag, which is the 1, 2, 3, 4, 5, 6, 7, 8th element on the stack. So guys, this was the format string vulnerability. I mean, the easy part that just leaks some data from the stack. The most difficult part, personally, is overwriting data with %n, because you need some math calculations there, and it's a bit more tricky. This one is straightforward, you just leak stuff and boom, it's done. I hope you guys learned something from the video and enjoyed it. If so, leave a like, leave a comment for feedback, and subscribe to the channel, and see you on to the next one. Bye.